Okay, I finished Professor Alberto Martinez's book, Kinematics, The Lost Origins of Einstein's Relativity. And as I've said before, I think this is the best book explaining relativity. And I'm making the claim here that what Martinez calls asymmetric algebra, which is like the secret of Einstein's relativity, actually is non-commutativity. And so after I finished the book, I looked up the Google Scholar articles that Professor Martinez had authored, and he's discussing in this one about how Henry Poincaré first discussed the simultaneity being conventional in principle, and because of the circular logic involved between speed and synchronicity or simultaneity. And so Einstein read Poincaré. I actually read that same book. It was published in 1905, Science and Hypothesis, something like that. So then Einstein, everybody knows about his famous thought experiment where he visualizes, he imagines moving along, and so when you have relative motion, then the observers would inherently disagree about the simultaneity. And so he was debunking simultaneity at the speed of light, or close to the speed of light. And so then what's really fascinating is Martinez says that the 1905 paper of Einstein on special relativity actually has been largely misunderstood because of the translation of German. And in German, they did not differentiate speed and velocity at that time in the physics when it was translated. So Einstein was actually talking about speed, and usually it ends up getting translated as velocity. But Einstein was actually using algebra, and so Martinez calls it a asymmetric algebra, and it can't be converted to vectors. So that's why it caused so much confusion, relativity, and it still does to this day. So I'm just quoting other articles by Martinez, and he goes back to Poincaré. So Poincaré never claimed that simultaneity is relative. He thought that there would be some way of synchronizing the clocks. But even though the simultaneity is conventional and not based on absolute time. And so there was a lot of research into this topic when Einstein, came out with his version, his argument for it. And that's what Martinez gets into that. And So the whole point was Einstein was disregarding the forces and just studying the motion as it appears to observation, and this is what was called kinematics at the time. So that's the title of Martinez's book. But later on, he talks about pheronomy, which would be the study of motion that's inherent to the geometry without needing to be observed. And that's what Basil J. Hiley also talks about, pheronomy, that Einstein focused on that also. So Martinez is explaining this, and then so Einstein basically was arguing that there's no true length of any body, and length is just a relational property due to relativity. So when you're getting close to the speed of light. And so then so basically Einstein was generalizing the Lorentzian transformations, so it wasn't just applicable to optics and electrodynamics. And then by setting the speed of light as constant, that's how he simplified the Lorentzian relativity. So in this case, Einstein would appear to have variations in the speed of light, but that's only due to the change of spacetime based on velocity. And so that's where you get that it's relativistic due to the space-time changing. So this is what caused a lot of the confusion. And so the reason this caused confusion is because of this image here. So I'm going to enlarge this image. So Einstein, he explained that you have rays of light emitted in opposite directions. So you have negative x, and then you have the speed of light times time, and then you have positive x and the speed of light times time. So so time had no direction to it, so it was just a length as magnitude for distance, and it wasn't a displacement. And so the problem is you could not translate Einstein's concept of time and light, speed of light, into vectors, and yet vectors were what all the physicists were using in electrodynamics. So there was an ambiguity in the Einstein's mathematics because he could equate the x as position, distance, and displacement. But also he could have displacement and position represented by negative numbers, and arithmetic itself did not capture the distinction between the physical relations, and to this day it still does not. So that's the difference between Einstein using an asymmetric arithmetic versus the vector math that inherently relies on a velocity and a squaring, so you can't have the negative numbers. So that's when I realized that there's this secret non-commutative kernel to Einstein's relativity, and I had never heard of that before. So again, Professor Martinez calls us asymmetries in the basic algebra. And then Basil J. Hiley, he also quotes Einstein, who admitted later in his life that Heisenberg was correct and that the space-time continuum would have to be rejected because you have this inherent non-commutative arithmetic in the algebra. And so when Einstein defined speed as a light path divided by the time interval, both that light path and time interval were non-commutative. Now, I'm calling that, so this light path is not, it's just a distance as magnitude without a direction. And so it's like a pre-space-time light path, essentially. And so when you connect it to space-time, then you get the non-commutativity. So I sent this off to Dr. Stephen E. Robbins because he and I he responds to my emails, and he did his PhD on special relativity and Henry Bergson psychology, and because Bergson had a big debate with Einstein, and he just he didn't even look at my blog, I don't think. Pretty sure he just, what I sent him in my email, he just said it was just BS, total BS. So that inspired me to look up more of Professor Martinez's articles, and I ended up finding this other article that I guess cites Martinez, and they talk about the Lorentzian transforms are actually non-commutativity or non-commutative. And then they say that this is generally overlooked in relativity textbooks, but it's clearly pointed out by Landau and Lifshitz, which are Russian scientists. So then this is the authors of that paper, Einstein's reinterpretation, how it turned out to be. Okay, so then they have more discussion about that. They say that when you have the Lorentz transformations are not commutative. So then I looked up the actual book that they cite, the Landau and Lifshitz, and it's literally, they literally are directly like basically cut and pasting the latter have the general property of commutativity. On the other hand, the Lorentzian transformations do depend on their order. And so that's exactly what they're just repeating what and then they also, this is the book that cited Landau and Lifshitz, and so then they have the exact same equation with the same comment about it. The equation here, we may point out that they are unsymmetrical, and this is due to the non-commutativity. Unsymmetrically and non-commutativity. So it's basically they just copied and pasted it. So that corroborated my own claim that I had realized from reading Martinez, because Martinez never mentions non-commutativity. He just calls it an asymmetric algebra. So when I looked up Martinez's articles and his books, well, his book is cited 33 times, so we can look that up. I looked up, his articles are cited quite a bit, 51. Okay, so let's see what this says. That's the book. Yeah, I already looked at this. This is how I found that article. So they're citing. So this looks interesting, velocity and absurdity. We can look at that later. So the other thing to point out is that when you study the black hole with the Hawking radiation, then relativity is inherently combined with quantum physics. And I was just reading DeWitt's article, and he basically says that it has to be anti-commutative. He calls it a ghost field, this anti-commutative ghost field. And then I just listened to Professor Basil J. Hiley's latest lecture, and he also talks about DeWitt reproducing the quantum potential. He rediscovered the quantum potential on his own, and I cite that here. I cited what's this one? So so the point being that yeah, this is also this talk was in March, but I just discovered it last night, and Basil J. Hiley actually promotes the Alon Khan talk that I sent to him, and he was really excited about that talk. And of course, Alon Khan is focused on non-commutativity and from music theory, and that's how I discovered Alon Khan was from the music theory connection to non-commutativity. So you have both Basil J. Hiley and Alon Khan connecting relativity with quantum physics through non-commutativity, and that's essentially what I've been studying. That's what I've studied for the past couple of years, and so you can see where he's promoting Alon Khan in his talk, and I don't see if he's mentioned it, but yeah, so Basil J. Hiley, they lost their funding to do the experiment that would physically prove the non-commutativity at the foundation of reality. I think they already did one experiment, but then with the pandemic kicking in, they couldn't. The money ran out, and okay, so that's where they're. So here you have Basil J. Hiley like dismissing the Schrodinger wave function, and he's discussing this with a German researcher. They're talking about Borne and Pascal Jordan, and so Basil J. Hiley, he talks about relativity in this talk, and he says there's this extra bit that they ignore usually in relativity, and that's actually what the quantum potential is, and that's what DeWitt basically discovered. So DeWitt also calls it anti-commutative as a ghost field, and that's what combines relativity with quantum physics. This is Bryce DeWitt from like in the he also worked on anti-gravity research. Oh yeah, so here he's talking about the Alon Khan. Yeah, right here, Alon Khan, right, on time emerging. That's the von Neumann algebras at type 3. So that's the lecture that I sent Basil J. Hiley. So that's like a big deal for me that he included that, mentioning that in this talk here. So this is a great talk where he goes into like just the mathematics of the non-commutativity sort of non-locality as it being non-locality, and then creating physics out of that. But when I talked to Basil J. Hiley, he said he's never really focused on gravitational entropy. So that's the difference. But anyway, so I recommend people go watch this talk by Basil J. Hiley, and I'll just leave it at that.